Hey guys, so I hope you liked that quick video on nets, and I want to take a screenshot here of this guy's excuse me presentation, and I want to see if you guys can actually do what he asked. Can you make a net turn into its actual three-dimensional shape? And so we have done here these three, and I want you to go ahead and try and hand draw or use whatever tools you need to from the classroom to draw them on just a piece of paper and see if you can make this. This one might be the hardest to imagine. Maybe you've seen it before. Maybe you think it just looks like Pac-Man. Wait, do you guys know what Pac-Man really is? I'm not sure. Well, whatever. Go ahead and give it a shot and spend maybe 15 minutes or so on that, and make it a group thing. You guys can do one project per group unless you really, really want to do your own. So do one of these nets per group. If you're feeling really good, you can try and do the opposite. You can try and think of a shape and then make a net of it. So for example, if you wanted to think of a pyramid, you could draw your pyramid in 3D if you're able to, and then go ahead and flatten it out and make a net of what you think it would be. And that'd be a cool little thing to start off with. If you haven't paused the video, go ahead and do so if you're still doing the nets. And I'll give you guys your time you need and then come back to this in a second when you are all finished. So now that you guys have had some experience doing nets, go ahead and take a look and see how we might be able to apply our knowledge of nets to find out some volume of shapes that we have. Can you see what this shape's going to be? How about this one? This one's a little harder, I think. You know what? Actually, let's go ahead and do this. Let's skip 24, and let's just stick with 23 for right now. Can you assemble that in your head? Can you see what kind of shape it's going to be? A key thing to look for here is whenever you have two identical shapes, in a net, it's usually a good indication it's going to be some sort of prism of that shape. So check that out. And then go ahead, once you've finished 23, try and tackle 25 and 26. Maybe take 15 minutes for this page, maybe 20, and then we'll resume on the next page with a couple of problems that actually came before this. So remember, do not do 24. Okay, here, so now that you guys have had some time to check out the previous page, this is actually the answers for that, and you can see I'm pretty sneaky because I have the Teacher's Edition book that a friend let me borrow online, and all I did a minute ago was do this. Check out right here. Erase. Erase. That's how I made the last page. Anyways, can I go back? No, I cannot go back. Here we go. Okay. So take a minute to look and see that you got the correct answers, and if not, you can take a few more minutes to try and figure out what you did wrong, and we will resume after the next one comes up. Okay, here's the newest page. Go ahead and take a look at this one. This top part should be pretty familiar to you guys already. This is stuff we've already covered. I bypassed number 19 because we really didn't cover these. However, the equation here is really going to be the same thing. You have to worry about the height, not the distance between the center points, which you might think, but it's actually the height. And there's a law this guy figured out that if you take one of these cylinders and you kind of move the top but not the bottom, it gets skewed like this. And you can find the volume of it just by knowing how high it is from the table, basically, to the top of the item. It doesn't really matter how skinny it is or how stretched out it is. This thing would be the same exact volume if, for example, you took the circle top and you had drawn it way over here and it's still connected back to that base. So it's still the same volume. Kind of how a triangle of the same height and base is going to be the same no matter what. Like this, for example. Make sure I got the right size here. Yeah, if I drew a triangle that is that high and has the same base, or like that in the same base. Pretend that I drew them the same height. They'd have the same area. And so it's kind of the same thing here. We have volumes that we're dealing with. And the rule kind of applies still. So you guys can try and figure that out. The rest of them should be good to go. You might take a little bit of brain thinking here to get them done. Do your best, and we'll try and make the best of it. Okay, here's your answer sheet. Check it out. Double check your work. You should be good to go. The class should be coming to an end. If you still have time left and you've mastered all this stuff, you may use the rest of the period for advisory or whatever Mr. Thomas wants you guys to do.